Okay, geometry, we're going to combine a couple of screencasts. I'm not sure why they split these, probably just to break the timing of it up just a little bit, but we're going to go ahead and throw them together. We are looking at trig ratios, trigonometry ratios. These will help us solve different missing pieces of right triangles. And on your calculator, this is where you are going to use these buttons. Okay, and what they stand for are sine, cosine, and tangent. Sine, cosine, and tangent. And so there's a little saying that we teach, and it goes a little something like this. Notice the first letter is S, C, and T in each of those three letter combinations. That's the sine, cosine, tangent. And this is pronounced so, ka, toa. And here's what it stands for. I'll put a little legend over here. O is for opposite. H is for hypotenuse. And A is for adjacent. And remember that adjacent just means next to. So when we are finding sine in a right triangle, we are going to take the opposite side over the hypotenuse. So, SOH, sine equals opposite over hypotenuse. Ka is cosine. And cosine is adjacent over hypotenuse. I should put the periods there because they are abbreviations. And then our last one is tangent. And you can probably see where I'm going with this. Tangent is equal to opposite over adjacent. And so let's do some practical work here. Let's create a right triangle. And I'm going to pick some sides. Pull one out of the book here. Let's go with 8, 15, and 17. So that's going to be the smallest side. 8, 15, and 17. And let's call this, let's label this ABC. So A, B, C. So here's all the things we can find. If I asked you what the sine of angle A was, well, sine is so, S-O-H, so I need to find the opposite side, and I need to find the hypotenuse. Now, you might ask opposite from where? Well, it's going to be opposite the angle that they're asking for. So if I go to angle A, which side is opposite angle A? And that's going to be 15. And the hypotenuse of this triangle is 17. So the sine of angle A is 15/17. Don't need to make it a decimal, don't need to do anything else. We're just finding what that actually is. So let's do cosine of angle B. Okay, cosine, here I'll write these up here. That was so, and then we have ca. So I am looking for adjacent over hypotenuse. So angle B, here's the question. You're going to say, well, there's two sides that are next to it, 15 and 17. That's true, but one of them is the hypotenuse. So the adjacent side is, go ahead and write that there. So the adjacent side to B is 15, and the hypotenuse is still 17. Now, you'll see these have the same value, and that's okay. We're going to use those in a little bit. We're actually going to find out what angle A and what angle B are. And so now we're not going to find a tangent of a right angle, so we're going to use A or B. So let's go with B. It's the new year. Everybody wants good abs, so that's ABB. And since B is Pearl, that's abs. So tangent is TOA. So we are looking at opposite over adjacent. Okay, so in this case, from B, opposite is going to be 8, and adjacent is going to be 15. Okay. Now, what if I actually wanted to find A and B? To this point, I don't have enough information. I do know that angle C is 90, so I know that A plus B has to equal 90, but I don't know which one is which. Now we have that information. Okay, so now we're going to do a little calculator work to find out what A and B are. Actually, we only need to find out what one of them is, and then we can subtract that from 90 to find out what the other one is. So let's start with A. If I'm going to find sine, again, this is calculator work, and most of these calculators are the same. The Casios might be a little bit different, so we can discuss that in class if we need to. So what I'm going to do is I'm going to take 15. I'm going to go up here. Whoop. I'm going to go up here and look at this one, and I'm going to take 15 and I'm going to divide it by 17. Because 15 over 17 is 15 divided by 17, and I get 0.882352941. So now I want to punch that in my calculator so my calculator actually identifies what the angle is, and here's how you do it. You're going to hit your second button if you're on the Texas Instruments ones. You're going to hit the second button, and you're going to hit your sine button. And then you're going to hit your second button again and go down to where your negative button is, where it has A and S above it. So you're finding the sine value of the answer, and you hit enter. And it comes out to be about 61.9. So that tells us that angle A is approximately 61.9. Excuse me. So if I got 61.9 here, so we now know angle A plus angle B had to be 90. So 90 minus 61.9 gives us 28.1. So angle B would be approximately 28.1. And that's how to find them using trig ratios. So we're going to finish with one big example. Maybe finding a missing angle, possibly finding a missing side, just depending on which one I pick. And so let's get to it. Okay, go ahead and hit pause, and then go ahead and copy this triangle down. Please don't just try to copy it down while I'm talking, because it is kind of intense, not too bad, but go ahead and hit pause. All right, we're back. Just a little over 10 minutes. We're going to finish with this example. And so I want to find that missing side. And so everything I've done with math so far has not prepared me for this. If I was going to find a missing side of a right triangle, I would need a squared plus b squared equals c squared. But I would need another side, and I don't have that in this case. But this is where trig functions are going, or trig ratios are going to help us. So don't forget our SOHCAHTOA. And so what we need to do here is we need to find out what is the relationship of angle 27 to the sides x and 15. Well, obviously x and 15 are not a hypotenuse because the hypotenuse would be this side right here. Okay, and so we don't know that one. So we obviously have adjacent and we have opposite. So which one do we have? So from 27, I have an adjacent of x and I have, oh good grief, that's horrible. I have an opposite. Whew. I have an opposite of x, and then I have an adjacent of 15. So which one of those uses opposite over adjacent? That's going to be tangent. So we are going to take the tangent of 27. I'm going to go ahead and put a degrees on there. And that's equal to opposite over adjacent. So our opposite is x. Our adjacent is 15. And what does this look like to you? It's kind of the beginnings of a ratio and a proportion. So we're going to solidify it into being a proportion by making that a fraction. Now, finding the tangent of 27, piece of cake. I just get on my calculator. I hit my tangent button, plug in 27, and that gives me a value of 0.5095, and it keeps going on. I'm going to go ahead before I erase my calculator, because I am cross multiplying, I'm going to go ahead and multiply that value by 15, and that gives me 7.64 and a bunch of other numbers there. And in this case, on these problems, I believe they want you to round to the nearest tenth. So when I cross multiply there, that's going to give me x equals, and that is 7.64. And if I'm going to round that to the nearest tenth, that comes out to be approximately 7.6. So that side is 7.6. Okay, if I wanted to find the other side, I could now do a squared plus b squared equals c squared because I've got all that information. Okay, so another lengthy one, a little bit over 13 minutes. Those are trig ratios, sine, cosine, and tangent. Don't forget the phrase SOHCAHTOA. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent is opposite over adjacent.